Hello everyone, welcome to the video solution for past paper. This is Edexcel IAL Physics, June 2019, a new specification paper, WPH11, Unit 1. So let's start. Question number 1. Quantities in physics are classified as either vector or scalar. Which of the following units could only be used for a scalar quantity? So if you see option A is meter second inverse, this is a unit of speed as well as velocity, so it can be used for both, for scalar and vector. As option B is ms minus 2, this is unit of acceleration, which is a vector quantity. kg ms minus 2, this is a unit for force. So all these three are vector, but kg m minus 3, this is mass, and velocity, it's a volume, so mass per unit volume. This is in fact density, which is a scalar quantity. So option is D, kg meter cube, only used for scalar. So option is D. Once in orbit above the Earth's atmosphere, the engines on a space rocket are switched off. Which row of the table correctly states the resulting motion of the rocket and the law explaining this motion? So remember, in an orbit, so this is the center of the Earth, and this is some space rocket circling around the Earth, and engines are switched off. That means the rocket is circling with a constant speed, but in a circle, as direction is changing, so this rocket is experiencing a force toward the center due to change in direction. And when the rocket has a resultant force, then the rocket must have some acceleration. So if you relate the force and acceleration, this is Newton's second law. So you cannot have option A and B. The reason is it is not you moving with uniform velocity. Remember, speed is uniform, but velocity is not uniform. Speed means its magnitude is not changing, but velocity is changing due to direction. So velocity cannot be uniform. So option A and B are gone. So option C and D, in both we have change in velocity, but we don't have any Newton's third law in this motion of rocket. So the motion of rocket in the orbit is due to Newton's second law. So option is C. Remember, Newton's third law is applied when you find some action-reaction forces, or Newton's third law pair of forces. Question number 3. A sphere of weight 2.5 Newton floats in a water with half of its volume beneath the surface. A force F is applied to the sphere, completely immersing it in the water as shown. Which of the following is the minimum value of the F? So if you see, the weight of the sphere is 2.5 Newton and it is floating with half of its volume. So 2.5 Newton is acting downward, and due to this 2.5 Newton, half of its volume is beneath the surface. So for rest of the half of the volume, you need additional 2.5 force, so that the ball or a sphere can be completely immersed in the fluid. So this F should be equal to 2.5 Newton, so that the ball is completely immersed inside the water. So the option is 2.5, 1 times of 2.5. Option is B. Question number 4. A ball rolls off a table with a horizontal velocity of 1.2 meters second inverse. The ball takes 0.92 second to reach the ground and lands distance s from the table as shown. Which of the following expression could be used to determine the value of s? Remember, it is all about projectile. S is the horizontal distance, and generally we say for horizontal motion, is considered as uniform because air resistance is ignored, and for uniform motion we use equation s is equal to ut, where u is the horizontal velocity or horizontal component, and in this case the initial velocity at which the ball is thrown from the table or rolls from the table, it stays same throughout the motion. So throughout the motion, the velocity, horizontal velocity is 1.2 and time taken is 0.9 second. So the distance can be found using s is equal to ut, and u is 1.2 into time is 0.9. This is the expression. So 1.2 into 0.9. So option is B. Question number 5. A sample of sea water is collected using a beaker. The sample contains some particles of sand which settle at the bottom of the beaker. Which of the following would result in a decrease in time taken for the sand to settle? Decrease in time, that means it will reach earlier. It will take less time to reach the bottom. And if you see the situation, first let's see, lower the temperature, higher the viscosity, so drag force will increase, so it will take more time. Similarly, smaller terminal velocity, that means it will take more time, so time will increase, time to reach the bottom. Similarly, a smaller particle will have a small terminal velocity. Particle is a small, it will take it will reach terminal velocity earlier. So a small terminal velocity, it will take a more time. So the only option is D, because the lower viscosity, so speed will be higher, it will take less time to reach the bottom. So option is D. Question number 6. A graph of a stress against a strain up to the breaking point is drawn for 4 samples of wire A, B, C and D. Which sample of wire has both a low elastic limit and a large region of plastic deformation? So lower elastic limit is all about gradient, and large region of plastic deformation is all about area under graph. So large region means large area under the graph, under the plastic deformation or permanent deformation. So if you see the lower elastic limit, A and B have a high elastic limit because higher gradient. C and D have a low gradient, that means low elastic limit, but we need a low elastic limit as well as large region, so large area. So option is C. C has lower elastic limit and large area under the graph, showing large plastic deformation. Question number 7. A water pump causes 200 grams of water to be ejected from the nozzle of a garden hose each second at a velocity of 3 meters per second. Velocity is given, masses are given. Which of the following expressions could be used to determine the minimum output power in watts required for the pump? So we need to find power in watt. That means we are using SI unit. So the mass should be converted into kilogram. That means it should be 0.2 divided by 1000. 0.2, that means option A and option C are immediately gone. And what about the power? Power is all about kinetic energy, energy per unit time. And in this case, because mass and velocity is given, so this energy is taken as a kinetic energy. So half mv square divided by t. And clearly, if you see m by t, this is the mass per unit time. So they are saying in the question 200 gram of water to be ejected in each second. So this is just not a mass, this is mass per unit time, or mass per unit mass per second. This is m upon t. So you can say that half, which is this, m by t is 0.2, and v square is velocity square, which is 3 square. This is the velocity. So half of 0.2 into 3 square, this is the power, and option is B. Question number 8. A model rocket is launched and moves vertically upward while still burning fuel to give a constant upward thrust. The fuel runs out and rocket reaches the maximum height at time t before falling back to the ground. Which of the following graph could show how acceleration A of the rocket varies with time if decrease in mass as fuel burns is neglected? Okay, so you need to understand motion of the rocket. So when a rocket is moving up with the increasing speed, the reason is the force acting or the thrust acting on the rocket is constant. So constant thrust means the rocket has constant acceleration when it is moving upward, when the fuel is burning. So during burning fuel, rocket is experiencing constant acceleration. So we cannot have option A and option B, because in both of the graph, the first portion of the graph is showing that we have increasing acceleration. So we cannot have increasing acceleration, because acceleration is constant. Because of this statement, rocket is experiencing constant upward thrust. So we can have either option C and D, because in both we have initial acceleration constant. But now what happens? Now you see this, suppose this is the ground and the rocket is going up, and suppose this is the point where the fuel just runs out. So when fuel runs out during this interval from bottom till this point, let's suppose this point is A. So till this point A, rocket is experiencing constant upward thrust, and so the constant acceleration. But as at point A the fuel runs out, it doesn't mean that the rocket starts falling backward. Rocket has some initial velocity, and according to Newton's first law, rocket keeps going up for some more time. You got the point. And but this interval is not due to a constant upthrust, because fuel is just finished. But due to Newton's first law, the rocket keeps moving upward for some more time, but this motion will be free fall. Free fall means this motion will be under gravity, under gravitational force. So in this interval we have acceleration 9.81, and it reaches here at time t. So in order to reach the maximum height in time t, the rocket has two types of acceleration. One is constant, the other one is 9.81. So if you see, the graph D is showing that at constant acceleration, rocket reaches at maximum height and immediately starts falling down. This is not the case. If you see, Rocket is experiencing constant acceleration due to constant thrust, and then fuel runs out and then keeps moving with the acceleration due to gravity, and at this time it is the rocket reach at maximum height and it starts falling down, and this falling this motion of a fall is again due to 9.81. So acceleration keeps going on with the 9.81. So option is C. Question number 9. A student walked 12 km on bearing of 135 and then walked 20 km at the bearing of 340. Diagram to scale. Okay. So which of the following could represent the final displacement of the student from this starting point? So because this is a scale vector diagram, clearly you can use a ruler and protractor to figure out, but in this question you need just only ruler. So you measure this vector, you measure the angle and try to draw try to join these two vectors, 12 km and 20 km, these two vectors with head and tail rule to figure out the resultant. So you can see that you can have and then clearly if you join head to tail, this is the head to tail joining, and the resultant would be tail of the first and head of the last. So this is your resultant vector R, or resultant displacement. So your option is B. Question number 10. A lift moves upward from rest with an acceleration A. A student of mass 70 kg is standing in the lift, exerts a force of 80 Newton on the floor of the lift. Which of the following expression could be used to determine the acceleration? So here they are saying this is the floor of the lift and a boy is standing, a student or a boy or person is standing here. So you can imagine the boy has a mass of 70 kg. So 70 kg is the mass, and due to this mass the boy has a weight acting down. But they are saying the boy is exerting a force of 800 Newton on the floor. So in addition of this weight, there is a contact force, that is the boy is acting downward on the floor of 800 Newton. Then according to Newton's third law, the floor will exert 800 Newton upward force, action and reaction force. And now see, lift is going upward, accelerating upward. So when it is accelerating upward, so how do you see this problem, this situation? Because this 800 Newton and this 800 Newtons are action reaction forces. But when you apply Newton's second law, so you need to see unbalanced forces because you have acceleration. So the unbalanced force would be equal to 800 minus 70g. 70g is the weight, mg, because mass is 70. So 800 minus 70g is equal to ma, and m is 70. So if you substitute 70 here, so option is C. Question number 11. A child is standing on a skateboard and both are stationary. The child throws a ball forward at a high velocity and the child and the skateboard moves backward at a lower velocity. Okay, explain in terms of momentum why the child and a skateboard moves backward at a lower velocity. Okay, so it's all about momentum and it is a question of explosion. So if you see in a condition before throwing a ball, the boy or the child and the ball both are at rest. So initial momentum before throwing is 0, when the child is throwing ball forward, that means the ball is gaining a forward momentum. But as initial momentum is 0, so after throwing, the total momentum should be 0. So in order to conserve the momentum, the child gains backward momentum, equal but backward momentum, so that if you add both the momentum, so the total momentum should be 0. And why the child is moving with the lower speed? Because of course the child has greater mass compared to the ball, so it should be moving with the lower speed. But when you multiply speed with the mass, so total momentum backward must be equal to total momentum forward. When you add these two, so sum of the momentum should be 0. That's how you can explain. Question number 12. Machines make work easier by changing the size or size or direction of a force. A student designed a simple machine to lift a box of mass 50 kg. The student claimed the efficiency of the machine was greater than 90%. The machine was used a slope of a height 2 meter and the length of 15 meter to move the box. The box was connected to an 8 kg mass by a rope over a pulley as shown. As the 8 kg mass fell, the box moved up the slope at a steady speed. Okay, this is 8 kg mass falling down, 50 going up. Determine whether the maximum efficiency of the machine was greater than 90% or what. So here, because we need to deal with the efficiency, so efficiency is output energy. So I'm just changing symbol. Let's see, efficiency is this curl E. It's just a symbol of efficiency, so you should not confuse. Output energy divided by input energy. And in this example, output energy is the work done on this mass. Work done on this mass, I'm calling it W1. And input energy is the energy lost by this hanging mass, which is gravitational potential energy. So it is the energy EI, and which is, you can say, the work done against the gravitational field, which is in fact a gravitational potential energy. So W2. So ratio between W1 and W2 will give us the efficiency. So W1 is the work done on the mass moving up the slope. And remember, when any object is moving up the slope, if you need to find the work done, so you need to use component of the weight, which is g sine theta, or you can say mg sine theta, as a force acting on the particle multiplied by distance. So W1 would be equal to mg or m1g sine theta into distance covered, because it is falling 2 meter down, so it will cover 2 meter up the slope, so times 2. But we don't have sine theta. Theta is the angle of the slope, but clearly sine theta can be found using opposite over hypotenuse. So I can rewrite this whole equation for W1. So W1 would be equal to 50 times 9.81 times sine theta, and sine theta is opposite over hypotenuse, which is 2 upon 15, into distance covered up the slope, which is 2. If you Use your calculator. So W1 would be equal to 130.8 joule, and remember this is the output energy. Now you can find input energy, which is W2 or EI, whatever you say. W2 is mgh, which is 8 times 9.81 times 2. It is 156.96, and joule. This is input energy. So efficiency is equal to output upon input. So 130.8 divided by 156.96 or 157, you can round it off. So efficiency would be equal to 0.833 or 83.3%. Clearly, efficiency calculated is less than 90%. So it is not greater than 90%, it is less than 90%. Thank you very much for this video. See you in the next one.